Hello, geometry students, and welcome to your first video on lesson 3.2 covering translations. All right, so translations is one of our rigid motions. We covered reflections in the last lesson. Today is translations. And again, when you think of translations, the layman's term word is simply a slide, right? So we are taking figures and we are sliding them either in space or on the coordinate plane. So here is our rule for translation. So again, a translation is a transformation in a plane that maps all points of a pre-image the same distance and the same direction. Same distance, same direction. All right, that's very, very, very key. Okay. So it says the translation of triangle ABC by x units along the x-axis and y units on the y-axis can be written as this. And this is your function notation for a translation. So the first number would be the x translation, and the second number is the y translation. Okay. So again, very important when you take a look at the properties of a translation. The segments connecting your pre-image and your image must be parallel, and they must be congruent. This is the same direction, same distance, which means that your figures should remain congruent, because this translation is a rigid motion. Length and angle measure are preserved. So if we take a look at this picture, A prime would be parallel to B prime, would be parallel to C prime. And the distances from A to A prime, B to B prime, C to C prime are all the same. Same direction, same distance. All right, so let's do an example here. It says, what is the graph of a translation 7, -4 of triangle EFG to triangle E prime, F prime, G prime? So this 7, -4 means we're going to go to the right 7 and down 4. Okay, so this is our translation rule. So let's take E. Let's go right 7. 1, 2, 3, 4, 5, 6, 7, and down 4. 1, 2, 3, 4. And there is E prime. F, 1, 2, 3, 4, 5, 6, 7, down 1, 2, 3, 4. There's F prime. And then G, 1, 2, 3, 4, 5, 6. Oh, wait. 1, 2, 3, 4, 5, 6, 7, and down 1, 2, 3, 4. And there's G prime. We went the same direction, same distance. And if we connect those 3 points, there you go. There is your image. Okay. Next example. So now let's come up with the translation rule. What translation rule maps STUV onto S prime, T prime, U prime, V prime? So we're going to look at 2 sets of coordinates here. All right. So I think I chose to do S and U. So how do I get from S to S prime? Well, I have to go to the left 1 and down 4. Left 1, down 4. How do I get from U to U prime? I have to go left 1 and down 4. There's your translation rule. We're going left 1 and down 4. I'm having trouble spelling the word down today. I don't know. So in our translation rule, look at this. We're going to translate in our little brackets of some sort. We're going to go left 1, down 4, and that's of STUV, and that's going to equal S prime, T prime, U prime, V prime. And there's your translation rule in that notation. Okay, last slide here of video 1. So we're going to take a look at what's called a composition of rigid motion. So whenever in math you hear this word composition, composition just means 2 or more of something, right? So in algebra class you might do composition of functions. Here we're doing composition of rigid motions. So the idea here is that if you take 2 or more rigid motions, the overall image when you're done is going to be a rigid motion. They'll remain congruent. Same preserve length and angle measure. So in this problem here, step 1, we're going to translate triangle ABC left 2 and up 5. Notice it's the second thing listed though in this parenthesis. This little open circle here, that's the composition notation, right? But step 1 is to do the translation, the thing listed second. And then step 2 is then to reflect across line L. So notice that when you do these compositions, you work right to left. You work right to left. So be aware of that. It's not normally you go left to right, but here you work right to left. Okay. All right. So I'm going to stop the video here. In the next video, we'll start with a example of a composition of rigid motions. All right, video 2 is coming.